In this video, I'm going to talk about one of the application using shifting and rotating instruction. Is a binary application. We have an example. We are going to multiply 123 by 36. 123 in binary format is this. 36 in binary format is this. We want to multiply these two together. When you multiply binaries, just like you multiply your decimals, 0 times this is all 0, 0 times all this 0, so you can skip 2 digits, move to this one, and this multiply by this, you copy them down to here. Follow, you have 2 zeros, 0 times all this, all 0, so you can skip it. This one, this times all this is 0, so you skip it. Now you do this one. This times all this give you one copy of this. And all these 2 digits are 0 when you multiply them to this. So this is the result we're going to add up, and this is the final result. The final result has 3 zeros in the front because we want to go by 2 bytes, that's 16 digits. Here, this is 1 byte. When we finish it, we have 16 bytes. And because the computer uses byte or 2 bytes, a byte or a word, a double word. So that's why you see 3 zeros here. The result when you multiply 123 by 36 should be 4428 in decimal. In binary, this should be the result. And if you add this up, you need to have 4428. Shift left allow us to multiply a number by the power of 2. So if you shift operand to the left once, you multiply the number by 2. That means you double the number. Use this knowledge, we can multiply something like 2's power or 2's multiples. The example here is UAX multiplied by 36. We can break down 36 into 32 plus 4. And 32 is 2 to the 5th power. And 4 is 2 to the 2nd power. So we can use shifting UAX to the left 5 times to get this result. And we get the UX shifted to the left 2 times, we get this result. Finally, we put the 2 results together to get the total result for this multiplication. So when we break down a number, we're always looking for the 2's powers. If you have 2's power, you decide how many times you're going to shift to the left. This is 2 to the 5th power, and we shift UAX to the left 5 times to get this result. This one is 2 to the 2nd power, so we decide to shift UAX to the left 2 times. This is the corresponding coding. Copy 123 into UAX, then copy UAX into EBX. We are trying to calculate the second part here using EBX. That's why we copy UAX into EBX. Then we're going to do this shifting. This is 2 to the 5th power, so we shift UAX to the left 5 times. This is 2 to the 2nd power, we shift EBX to the left 2 times. And finally, we add EBX into UAX, and UAX is holding the result. Here, there's another example, and we're going to multiply AX by 26. 26 can be broken down into 16 plus 8 plus 2. This is 2 to the 4th power, 2 to the 3rd power, and 2 to the 1st power. Then we can do shifting. This is the coding. Copy. You need to initialize AX. Whatever you can put into AX, that's fine. So initialize AX with 2, then you can copy AX into DX. That means they're going to use DX to do maybe this or this or this. So let's see. you're going to shift left ds 4 times. That means the ds is holding 16 as the result. Then push edx. That means save edx is the result. That means save this one to the stack. Then copy x into dx again. That means you are trying to multiply ax by 8. To calculate ax multiply a, you're going to shift dx to the left 3 times. Finally, you're going to shift left ax once. That means x is holding this result. To get all these 3, ax times this times this times this, you need to add up whatever in here. That means shift 3 times here, dx into ax. Then pop edx. That means get the one you save to the stack. Whatever is you push it here in the stack. That means ax times 16 as a result in the stack. Pop, that means restore the result into edx. Then you add whatever in edx into ax. So this will hold the result ax multiply 26. That's the result in ax. Let me show you the coding part in Visual Studio. Let me copy paste the code from my PowerPoint into my Visual Studio so I can run this code and test out the code. Okay, I'm going to indent this a little bit one more time. Okay, this a little bit. Okay, let's see if I need to modify anything. If this code is right, this should be fine. They said they want to use ax, they don't want to use eax. So here, let me modify this into ax. After everything finished, I should have ax holding the result like it said over here. Okay. To print out the result, I can use a library function called write DEC, write in decimal format. This is going to print out whatever is in the UAX. Okay, before this, let me go ahead. Okay, after this, I need to call CRLF. I want a new line character after my number there. So let me build to see if I can run. Okay, it's fine. Let me check out the result. Makes sense to me or no? Oh, the result is huge. Let me check out what's the result. I have 2 times 36. My result should be 72. Why is a huge number? That means somewhere is not right. I mean, could be about AX there. So before I use AX to hold 2, I can clean up UAX. I want to control what I have there. So I start with a good result first. I have faced the problem, and to run this code correctly from the PowerPoint, you need to make sure you clean up UX before the first statement here. Otherwise, you have a garbage in, garbage out. Your result is kind of like garbage. So this line is very important. After this, and I tried my code, it's working right. See, this is 52 because I have 2 for AX times 26. That's 52. That's right. Thank you for watching.